Bismillahirrahmanirrahim. Today I would like to present flat plate solar collector simulator. As we know that the flat plate solar collector is used to heat water by two modes. First mode is passive or thermosiphon mode, where the circulation of the fluid occurred due to the buoyancy forces produced by the differences in the densities of the fluid in the collector. Or the heating of water decreases its density, causing it to rise through the system. The second mode is active mode, where the circulation of the fluid occurred by an electric circulation pump. Let me introduce the equipment and operation of the simulator. First, we are having a storage tank used to store fluid, and having the collector or observing plate to heat the fluid inside. And also we are having two special type of lamps. It is producing solar intensity. This is not the ordinary lamps that is used in the houses. The electric circulation pump for active mode, and also having different types of valves to control the flow. Regarding to operation, we can run the simulator as an passive mode or thermosiphon mode. So the water is coming through this pipe, and it will go directly to the observing plate. So that valve in the passive mode or thermosiphon mode, it should be opened, and the circulation pump should be turned off. And if you want to run the same simulator as an active mode, so we should close that valve, and the water will come through the circulation pump. It will pressurize the fluid, and then the water will come through the flow meter. It will measure the flow rate, and through this pipe it will go to the observing plate. And furthermore, we can make many changes to the flat plate solar collector. For example, we can change the tilt angle of the upper surface, tilt to this elevation, and the bottom surface is fixed. We can only change the tilt angle of the upper surface where the lamps are attached. And also we can increase and decrease the intensity of the light. So there are 5 thermocouples connected to the simulator. The first thermocouple is this one, connected to the storage tank to measure the temperature of the tank, and the second thermocouple is connected to the pipe where the water is coming out from the observing plate. And also the third thermocouple is connected to the 5 where the water is entering to the observing plate. And also the fourth thermocouple is this one, measuring the temperature of the observing plate. And the fifth thermocouple is this one, measuring the air temperature, ambient temperature. And this is the controlling machine that controls the intensity of the light and the flow rate of the pump, and also reading the data of 5 thermocouples and 1 flow meter. It can be connected very easily. Just see the label. For example, this is ST1. We should connect to. Here it is written to the ST1. And also this black wire should be plugged in here. For example, this is lamp panel. This is the wire for these 2 lamps, so it should be plugged in here. And this is the wire for the pump, so it should be plugged in here. If you want to operate the system in thermosiphon, so this wire should be not plugged in. If you want to operate the system in the active mode, so we should plug in this wire. In order to simulate the flat plate solar collector, you can open the SCADA software. Yes. You can see the diagram of the flat plate collector here with 5 thermocouples and 1 flow sensor. And you will see the measuring temperatures here from ST1 to ST5, and the SC1 is the flow sensor. If you want to compare two graphs, so you can select graph A or graph B, or if you want to see all the data in a single graph, so you can select this single graph. In order to show the data of pipe thermocouples and flow sensor here, you should select all these: ST1, ST2, ST3, ST4, ST5, and SC1 per flow sensor. Here you can control the lamp intensity from 0 to 100, and you can put, for example, let's put 100. Here we put it. Then let's start the simulation. We should press start. Here important thing is we should add extension to the name. For example, let's name the file KFUVM. This is the file name. Then what will be the extension? This is the extension .dat. So here, then okay, then you can see that the simulation has started. So we should press this quickly, save data. So now it's reading the data and measuring the data in each second. So here you can see the graph. So after, you will see that the temperature of the water will increase. Here you can see the flat plate solar collector, the lamps are turned on. And also the important thing, to reduce the convection loss and also make the intensity maximum, we should open this blend. We are having a blend here, so we should open this blend in order to reduce the convection loss and make the solar intensity maximum. So here we should open the other blend also. Here you can see. Now here it is recording the data. We want to end the experiment, so we should click stop, and you will see that it turned off the lamps. It ended the experiment. So then we should go to view data in order to see the result in Excel file. So which was our file, kfuvm dot. This was our file. So I will copy this and here paste. So this is our file, but in dot extension. So I will open an Excel file, Windows, so here we should come to open. Here we should select all files, then desktop. Here kfuvm dot, this is our file. So select, then open, then next, then select the comma, then next, finish. So here this is our data. Here the time is in second. This is the data for pipe thermocouples ST1 to ST5. Flow sensor is 0 because it was in thermosiphon mode. This is the lamp with 100% intensity.